So I just wanted to show you a bit of a fun project that we've been working on to support the Greenpower electric car challenge. Our entry for it. This is not our entry, this is just a search that I did on the internet, but it gives you an idea of what the car looks like. And you can see this I2C LCD display is displaying volts, amps and temperature. So this is the temperature sensor here, and if I try and warm this sensor up a bit, I think the outer casing creates a bit of a lag because it's slow to heat it up and then slow to cool down again, but there you go, it's heating up. And you've also, so that is the sensor for the temperature. So the sensor for voltage, which was fairly simple to do, is this little thing here. So you've got plus and minus that go to the breadboard rail, just giving this sensor power, and this yellow signal pin goes to one of the pins on the Pico and provides data. So these two white wires are going to a battery. Okay, just so I've got a reading going into that sensor. Yes, it is a bit of a knackered battery because that should really be 12 volts. So the amp sensor was perhaps the most fiddly to do, not that bad, but here you go. It's basically you need that arrow to be going in the direction of the load. So you go from the battery, okay, and this goes to, I had it on a fan and a couple of other things. It's not really under load at the moment, but basically I connected up a load here. So just to be clear, that arrow needs to be pointing to the device that is pulling current from the battery. Okay, so again you've got a plus and a minus wire just providing power to this sensor, and then the yellow signal wire is going to an analog pin on the Pico. So when I'm developing new resources and how to use these screens, for example, I like to create a guide so I can come back to it later. And this one talks about the libraries that you need to install. I did originally do one with the WavShare one, but that's more expensive and it uses slightly different libraries. So the Freenode one you can buy dirt cheap off places like AliExpress. So you've got wiring pins. They can come in a slightly different order, so you just have to be aware, and it's fairly logical. You also get ones which have a sort of separate black circuit board, which is the I2C converter, and the version 2 ones which are built in. This is the wiring diagram. I was using these two signal pins and the other two went to the rail to provide power. So the code, as always, I like to decompose it. So once you've installed the libraries, you need to install the LCD library, this one and this one for the Freenode. They have to be installed on the Pico, and you can search for them easily to get the GitHub page. Once you've set them up, you can wire up according to the wire diagram that I showed you, and then basically you have to do a scan so that you know the exact number to put into your code, and then you've got some test code that you can use just to check exactly how it's working. And this is the test code I use for the LCD screen. So that number has to match the scan that you did, and these are the pins, okay, and all it's doing is it's outputting some string to the LCD screen. Okay, so that is basically getting the LCD screen working. So then I moved on to the voltage sensor. So this is my guide for the voltage sensor, and you can see from this picture pretty clearly that you've got 3 pins that wire up to the Pico. You've got your power that's powering the sensor, nothing to do with the battery being measured, and you've also got the signal pin, which I tend to use yellow for, which sends data that we can then use and display to the LCD or just in the Thonny shell. So again, these things are cheap as chips, they're really easy to use, and I used this pin for it because it's an analog pin. These 3 are all analog pins, and this is basically how you wire it up. So your battery goes onto these big blue blocks, and then you can measure the voltage on the battery. It goes down this yellow signal pin, and then you can output it to the shell just to check your code is working. So that's the wiring diagram. And then this is the test code that I used just to check. So it's a completely separate program to the LCD screen, where I'm literally just checking and doing a while loop to check that my GPIO pin 28 is getting a signal that is allowing me to read the voltage in the Thonny shell. So that's the voltage sensor. So then on to the amp sensor. So this is the amp sensor I'm using. They're pretty commonplace, they're not too expensive, around about a £5, perhaps less if you got them from AliExpress, and not too many pins to worry about, and a little bit of information about what amps are. So the amps are basically the how much energy is flowing through the pipe, you know, how much your device is drawing through the pipe. Okay, pretty easy to wire up. We're using the VCC, that's the plus power, providing power to the sensor, and you've got the ground, which is the minus side of the power circuit, and then we're using this analog signal analog out, which is where I use the yellow color wire to provide data to the Pico. This level signal output, you can use that to connect to a relay, so if the amperage goes above a threshold, you can make it trigger the relay and turn something off, for example. This can be adjusted, that threshold can be adjusted here, but I haven't really used that yet. And this is the wiring diagram, nothing too surprising here, and I'm using GP26, so that's another analog pin. Something that was a bit different was the configuration. So we need to configure the sort of software so that we get a good reading from our sensor. So this is the test code that I found and developed in a small way, and you can see here that we need this because we are working out what the average resting voltage is. So it's the output from this program gives me a reading. Okay, so it takes 10 readings, one every half a second, and then averages them, and we need this to go into our main amp sensor program. Okay, so this code is just what I'm calling the scan code that allows us to identify a resting voltage. Okay, so this is the main program for the amp sensor, and again I've decomposed this. I'm not worrying about LCD screens or mixing it up with the voltage sensor or the temperature sensor. This is just the amp sensor I'm looking at the moment. This is the pin the Pico pin that it is sending data to. This sensitivity reading needs to be adjusted. Mine is a 70 amp version, but you can get 30 amp or 20 amp versions. So if it's the 30 amp, this value here shouldn't be 36, it should be 66. And if you've got something else, if you just look up the data sheet for this device, it tells you what you need to know. So this confused me slightly because the Pico can output 5 volts on the VBus pin, and I wondered if I needed to change that to 5 volts, but actually it's the actual ADC pin, so the analog pin, where the data is being sent to the Pico from the sensor, and that is 3.3 volts. So that's what this just needs to stay as it is. And then this is a while loop that reads the values and then outputs the information just into the Thonny shell, as you can see here. I'm getting a kind of a weird reading, this minus reading, and I'm getting about a 200 milliamp variation. I think this is because it's not under load. So time will tell if my settings here are not particularly accurate, but it seems pretty accurate. I put on a little sander thing that should pull between sort of 2 and 6 amps, and I was getting consistent readings with that. So this is the code for the sensor, and it's being configured. So then what do? Well, basically you need to bring all these things together into one program. And you don't really need me for that. I think it's something that anybody can do with a bit of patience and a logical outlook. So you've got here the amp sensor sort of variables and the pin settings. That's for the amperage sensor. And then here we've got the temperature sensor libraries and pins and variables. And the same for the voltage sensor, so obviously that's using pin 28. So I'm bringing together all those decomposed programs that I know work. And then there's the LCD libraries that we need to output data to the LCD. And then one big while loop which reads the voltage data, reads the temperature data, and reads the amperage sensor data. And then we have to display all that information into the LCD. So this is going to be useful because we'll use temperature to read the battery temperature to make sure it's not overheating. Amperage is how much the motor is going to be pulling energy through, and the voltage is just making sure that we don't run our batteries too low. Obviously lots of other things that we could be doing. I'd quite like to maybe even have some sort of G-forces involved, so some 3-axis gimbal sensor. We could have some readings for speed pretty easily in the same kind of way you might do with a push bike, attaching a magnet to one of the wheel hubs and then reading revolutions. But one thing at a time. I think this is enough to install in the car as a first build.